Hello everyone, welcome back to the channel. Today, let's talk about the atomic number, mass number, and some other stuff related to it. And if you haven't watched my previous videos, make sure to watch it as it's help you to understand the concepts we are exploring today. Let's start. I think now you all know that this atom is very tiny particle. So even though this atom is very tiny, this atom, each and every atom is having its own identity. And it's like a fingerprint of an element, telling us exactly which element we are dealing with. So this atomic number is helped to identify each and every element in the periodic table. So how this number was given? Actually, this was founded by a scientist called Henry Moseley in 1913. He used a X-ray spectrometer, and then he was able to found that the atomic number is directly correspond to the positive charges or the protons in an atom. For example, if we take sodium, it is having 11 protons, so that we can say its atomic number is 11. So when we consider the periodic table, you can see that the sodium, this is how the sodium's atomic number is represented. So like that, each and every element in the periodic table is having their own atomic number. Now let's move into mass number. So what exactly this mass number means? So this concept was developed as the atomic theory was advanced in early 20th century. So there is no one exact person to discover the mass number, but the concept was emerged from the work of the Ernest Rutherford. So according to that, we can say the mass number is the sum of number of protons and neutrons. So for example, if we take the same thing, the sodium, it has a mass number of 23. So now, if I ask a question from you guys, how many neutrons present within the nucleus of sodium atom? I think now you know the answer. It's actually 12, because we know that the atomic number is equal to the number of protons. So earlier we found that the sodium is having 11 protons. So the number of neutrons equal to the mass number minus the number of protons. Then we found that the sodium atom has 12 neutrons. Then this is the symbol which denote the mass number. So most of you may confusing that this is the symbol for the atomic number, but actually it's not. So this is the symbol that representing the mass number. So this is the whole representation of the atom. So this is how we going to represent the mass number, atomic number, and the element. So for each element in the periodic table, this is the standard. So when you're going to write the mass number or the atomic number, you have to write like this. Now, I will give you a very small question. So before the explanation, I want you guys to pause the video and find the answer by yourself. So this is the question. How many number of protons and neutrons are there in an atom having a mass number 12 and when the atomic number is equal to 6? So the answer is the number of neutrons are equal to 6 and the number of protons. So we know that the atomic number is 6. So therefore the number of protons is also 6. So what exactly this element? So using the periodic table, we can find it. So here in the periodic table, I think now you can find in which place this atomic number is represented. So the atomic number we can find, the atomic number of 6 is we can find in the group 14. So in this one. So this is the carbon atom. So this element is now, we can say it as the carbon atom. Alright. I think now you got a clear idea about this atomic number and mass number. Now we move into the relative atomic mass of an atom. So what is this? So this concept was introduced by a scientist called John Dalton in early 19th century. So relative atomic mass is the average mass of all the atoms of an element. It was compared to the 1/12 the mass of carbon-12 atom. So it considers the masses and the abundances of all isotopes of that element. So let's understand this whole thing using an example. I think it's easy. So this is the equation for the relative atomic mass. And this is how we're representing it, the symbol. And the average mass of an element is divided by the mass of one atom of carbon-12 into 12. Then the example is this. So now we're going to finding out the example, the relative atomic mass for the chlorine. So for the chlorine, it is having 2 isotopes. So when we take chlorine 35 with a mass of 35 and abundance of 75%, that means this chlorine 35 is the most abundant isotope from chlorine 35 and chlorine 37. So chlorine 35 is having the abundance of 75%. So if we write it as a fraction, we can write it like 0.75. Then for the chlorine 37, with the mass of 37 and the abundance is only 25%. So that's how and then as a fraction, we can represent it as 0.25. So then after that, what we're going to do is, now we're going to add the results to get the relative weight. Because now we know that the chlorine atom is having 2 isotopes, and then we multiply this mass of each isotope by its fractional abundance. So fractional abundance is here. So we multiply the 35, which is the mass, with 0.75. And 37 mass is multiplied by 0.25. And after multiplying these two, now we're going to add the results to get the relative weight. Alright, then this value reflects the average mass of all chlorine atoms, considering their natural abundance. So that means we will get by adding these two, but we get the answer as the relative atomic mass, it is 35.5. So this 35.5 is the relative atomic mass of chlorine. So I think now you understood this, what it mean by this whole thing, because the relative atomic mass here, they say the average mass of atoms of that element. So here we took the average and finally we got the answer as 35.5. I hope that you understood it. Now let's move into the atomic mass unit. So atomic mass unit is a unit of mass used to express the atomic and molecular masses. It is defined as 1/12 the mass of carbon-12 atom. So this concept was founded by a scientist called Jean Perrien, and he did a great contribution in defining this atomic mass unit. So with his discoveries, he later gave a constant which represent the mass of one atomic mass unit as 1.66 into 10 to the power minus 24 grams. So this 1.66 value was given by the scientist, and it is this value we consider it as a universal constant. That means this universal constant means it is a physical quantity, and this value has to be same in everywhere in the universe, and it should not be changed over time. So that's makes so then we can use in various calculations, like for the molar masses calculations we are using this value. So I think you guys may have a question that regarding the difference between this atomic mass unit and the relative atomic mass, because it's like the same thing. You may, but it's not actually the same. It's like this atomic mass unit is something, it's like it is having a specific unit. But for the relative atomic mass, it is a ratio. It has no units. Like if we take the same example, the chlorine, we found that the chlorine is having the relative atomic mass of 35.5. So at the same time, we will get the atomic mass unit of the chlorine as 35.5. So this atomic mass of a, so this 35.5 is the atomic mass of a single chlorine atom. So the value that we give is like approximately we find out that it has 35.5. So then this relative atomic mass is the weight and average of these isotopes. That means chlorine 35 and chlorine 37 isotopes. And then what we got from the relative atomic mass is the average. So this value is dimensionless and represent the average mass of chlorine atom relative to 1/12 the mass of carbon 12 atom. So even that means both of them have the same numerical value, because the reason for them to have the same numerical value is because we use the same standard, this 1/12. So in the definition you can see that here also we use the atomic mass unit, and it is the 1/12 the mass of carbon 12 atom. Same as that, in here also we can see we compared it to the 1/12 the mass of the one atom of carbon 12 isotope. So for the both cases we use the same standard. So that's why we got the same numerical value. So but the difference is, for the atomic mass unit we can get a unit like the gram. But for the relative atomic mass, we are not putting any units for that. So I think now you got the idea about this whole thing and regarding those differences. You can give your ideas in the comment section, and please don't forget to subscribe my channel. Alright, that's all for today. See you in the next one.